Good day everyone, my name is Jean Marlwin L. Gamboa. I'm the programmer in this group. I'm responsible for making the program and explaining the program in our Arduino.
Good day everyone, my name is Arshad Ajihit. I am one of the designers in our Arduino project.
Good day everyone, my name is Jerobic Hebalistaras. I am the documentator of this group. I am responsible for checking and managing the Arduino hardware and software, checking the condition of each components.
Good day everyone, I'm Luis Enrico, aka Tos, and I'm one of the Arduino designers. And together,
We are the Group 4 BGQA TRONIX.
Arduino project number 7. This project is all about a system designed to monitor temperature levels and trigger an alert when a predefined threshold is exceeded. It uses a temperature sensor to read an ambient temperature, an Arduino to process the data, and a buzzer to sound an alarm when the temperature goes beyond the set limit. So let's go ahead and start the Arduino project number 7.
Hello everyone. For our project number 7, the temperature alarm, we'll need a new components. Let's get started. First, the Arduino Uno with prototyping shield. This is the main controller for our project. Next, the LM35 temperature sensor. This measures the temperature of our project. Third, the buzzer. This produces alarm sounds when temperature is high. And the last, the jumper wire male-to-male. This connects all the components for our project. This will be the step-by-step building for the project number 7, which is the temperature alarm. We need the Arduino Uno prototyping shield. Next, place the LM35 sensor on the board. Next, the buzzer. Connect the buzzer to the board. And then, get the jumper wires, connect it to the positive, and the end to the 8. Get the another one jumper wire to the negative and to the ground. Another jumper wire for the end of the sensor going to the 5 volts. Another jumper wire to the center of the sensor going to analogy 0. And the last jumper wire going to the last sensor and going to the ground. And that's it. That is our Arduino design for project number 7, temperature alarm.
Here is the code behind our Arduino project number 7. Temperature alarm. Float scene val. A variable that can hold decimal numbers. We'll store a sign value here. Int tone val. An integer that will hold the frequency in hertz. Sends to the buzzer. Unsigned long step timer. A variable used to remember time from millis so we can do things periodically, like print every so often, and unsigned long is the correct type for millis values. Void setup. Start of the setup function. Code here runs once when the board starts. Pin mode 8 output. Configure pin of buzzer. Serial begging 9600. Configure baud rate to 9600 bps. Void loop. Start of loop. This runs over and over again. Int val. Save the value of LM35. Double data. Save the converted value of temperature. Val equals analog read 0. Connect LM35 to analog pin and read value from it. Data equals double val times 5 over 10.24. Convert the voltage value to temperature value. If data is greater than 27, so if temperature is higher than 27, the buzzer starts to make sound. For int x equals to 0, x is less than 180 x plus plus. Convert sin function to radian. Sin val equals sin x times 3.1412 over 180. Use sin function to generate frequency of sound. Tone val equals 2000 plus int sin val times 1000. Configure the buzzer pin 8. Tone 8 tone val. Play a square wave at tone val hertz on pin 8. Delay 2. Pause 2 milliseconds before the next X value. Controls how fast the pitch switch moves. Else, if the temperature is lower than 27, turn off the buzzer. Note tone 8. Turn off the buzzer. If millis step timer is greater than 50, every 500 ms serial ports outputs temperature value. Step timer millis. Serial print temperature. Serial port outputs temperature. Serial print data. Serial port outputs temperature value. Serial print line C. Serial port output temperature unit.